The University of Illinois at Urbana-Champaign School of Architecture Computing Department presents the Laser Cutter Tutorial, a beginner's guide to setting up files in AutoCAD and executing cuts. Currently, there are 4 laser cutters available to you through the creation of a reservation via the TRS online system. The laser cutters will not automatically create the model for you. Instead, you have to first develop an assembly strategy which is often dependent upon your material type and thickness. Next, you will have to break your design down into a 2-dimensional plane by laying out the pieces in AutoCAD. After performing the high precision cut with the laser cutter, you will be ready to put the model together, eliminating the need for the use of a traditional X-Acto knife. In this tutorial, we will cover the following: set up your cut and score layers in AutoCAD, create a material template for reference in model space, properly scale your drawing, run the Express tools in AutoCAD to ensure a fast and efficient cutting file, tips for cutting and scoring text, set up the laser cutter printing properties, and lastly, configure and use the laser cutter based off your material type. Before we start using AutoCAD to set up our file, let's first cover the basic components to the laser cutter machine. The laser cutter moves along the rails on the x-axis and y-axis directions. The laser tube, shown in yellow, shoots a laser out that reflects down the left y-axis rail to a mirror, then down the x-axis rail through a lens to burn the material. The material being cut is placed on top of the laser cutter bed, which consists of a honeycomb grill to circulate air and collect fallen pieces. Beware, once pieces have fallen through, they are considered lost. The Cartesian coordinate system is used to map what is seen on the computer screen to the laser cutter bed. It is easiest to assume the drawing origin is at the lower left-hand corner of the laser cutter bed when facing the machine. The coordinates are 0, 0. This will come into play when we configure the printing properties. Once the machine is started, a continuous laser beam is reflected off the mirrors to burn the material. The cut produces a bright white light and, as a precaution, should not be stared into, for it can cause retinal damage. Go to the Start menu. Under the CAD and 3D Modeling folder, open AutoCAD. There are 2 versions listed. Make sure you choose the regular AutoCAD because it has certain commands architectural AutoCAD does not have. Adjust the units so they are set to architectural when working with a new file. Click OK. We need to set up the cut and score layers in the Layer Properties Manager so the machine knows what to do. Go ahead and create 2 new layers. Double-click on the name to rename the first one to Cut, and then rename the second one to Score. Change the cut layer color to red. When selecting from the color from the different shades, make sure you choose only from the list of true colors listed below the shade gradients. For the score layer, make sure you choose the true green color, and then click OK. Make sure not to assign any line weights to any of the layers, and now we are done. It is useful to know where the machine will cut the material when it is placed inside the laser cutter bed. We will draw reference lines to represent this. All reference lines should be placed on the 0 layer to make sure they will not be cut or scored. Draw a rectangle to the dimensions of the laser cutter bed that you are using. It will either be 18 by 32 inches or 18 by 24 inches. Once done, go ahead and zoom extents to view your entire drawing. You may want to move the UCS out of the way for a clear view. Just like any other file you would send to a printer, you have to account for the margins around the perimeter due to the physical restrictions the machine has getting to the very edges. A 1/4 inch offset is a good rule of thumb to follow. We drew the printer reference lines to real scale in model space, which more than likely dwarfs your actual real scale building drawing. To remedy this, we will use the recommended method of scaling to enlarge the material or printer reference template by a factor related to the final model scale. This will allow us to position our elevation on the template with no adjustments to the building's real measurements. Finding the scale factor is easy as multiplying the print scale by a unit conversion. Since we are working in feet and inches, the unit conversion will be 12. Open the calculator tool. Say we want our model to be 1/64 inch scale. Multiply 64 by 12 to get the scale factor of 768. Activate the scale command and then select all the reference lines and hit enter. Snap to one of the edges, drag the cursor to the right, and enter 768 for the scale factor. Go ahead and zoom extents. You can see that the drawing will now fit within the reference lines. Go ahead, select the building, and move it within the template. When you are ready to print with this scale method, make sure to choose the print scale in the plot properties 1/64 of an inch is equal to 1 foot 0 inches. Pick a window for the plot area. Select the perimeter of the reference lines as your window to scale everything down to 1/64 of an inch. The alternate scaling method is the exact opposite of what we just did. We will now scale down the drawing to fit within the reference lines instead of scaling up the reference lines. The formula now is the exact inverse of the previous formula. It will be 1 over the drawing print scale times the unit conversion factor. Open the calculator tool and multiply the drawing print scale, which is 64 because we are making a 64th inch scale model, times 12 for the unit conversion factor, and then take the inverse of that. Go back to model space. Select your drawing, which is the building elevation in this case, and activate the scale command. Select a base point and drag the cursor to the right and then enter the decimal number you just calculated. You will most likely have to search for the scaled down building elevation drawing. Once you have found it, place it within your reference lines. Before you plot, you will have to choose a plot scale equal to true size now, which would be 1:1, because you technically already scaled the drawing down by a 64th inch scale factor. Select a window for the plot area, and then select the perimeter of the reference lines.